Hello, hello. Sir, are you hearing me? Hello, hello everyone.
Hello, yes, sir.
The feedback form of
Okay, so let me send the link in the message.
yeah, ma'am. It will be
Okay,
better. Thank you, ma'am.
okay, sir.
Yeah.
Akriti, can we start now?
Yes, sir.
Dr. Arif, Dr. Arif sir, are you there?
Yes, sir. Good afternoon.
Welcome, sir.
Thank you so much,
Akriti,
sir.
please. Yes, sir. Participant, so we are starting. Thank you.
On behalf of all the participants, I welcome Dr. Arif Anwar to deliver the session on exploratory and confirmatory factor analysis using SPSS. Dr. Arif Anwar is currently working with Asian Business School as an assistant professor. His thrust area is marketing and operations. He has considerable amount of experience in teaching with subjects like marketing, operations, and business research methods at different institutes of learning. Dr. Anwar has earned his degree of PhD from Aligarh Muslim University, and he holds the degree of MBA in marketing and operations from Jamia Millia Islamia and a BTech degree from GGS IP University. Certified UGC NET in management. Sir has publications in journals of international repute He has been participating in conferences, workshops, and MPs for continuous learning and intellectual development of various of various institutes in India and abroad, including IIM Calcutta, IIM Indore, Harvard University, University of Applied Sciences, Srinagar, and BITS Pilani. Dr. Anwar has been mentoring the students and professionals for their startups, innovation, and incubation journeys. I again welcome you, sir, to start the session. Over to you, sir, Dr. Arif Anwar, sir.
Thank you so much, Professor Akriti. Thank you for this nice introduction, everyone. And I'd like to first of all congratulate Jamia Hamdard for bringing such a nice thing, such a needy thing for the community of scholars out there. So thank you, all the coordinators, Jamia Hamdard, and a special thanks to ATAL, the AICTE Training and Learning platform. Today my session is completely related with uh, the use of SPSS. So the very first thing that I'd like to tell each and every one of you that please consider this session uh, as a platform of learning and interactive session that will help us to use SPSS not as a tool but just as an aid. Because many of times when I was pursuing my research, my PhD, along with my colleagues, we had a very bad perception or a negative perception about SPSS, that it solves all the problems that we have in research. So this is not actually true. Uh, the basic thing is SPSS just lets us know that what kind of problems that we are having, and the data that we have and how exactly we have to analyze it. So it's just a facilitator. The very basic thing I'd like to tell each and everyone today, all the participants, all the friends, scholars, the academicians, and all the repeated persons out there, that this learning is just from the perspective of knowing another dimension, another platform where we can do the analytics, do the analysis in a very smooth manner. Although we know that the way SPSS looks like, this sheet is quite similar with Excel. And believe me when I say that for majority of the tasks that we have, we should not, or we might not require SPSS as a whole. So it's not I'm promoting SPSS, or I'm degrading SPSS right now. The very basic thing that I have to say is just use it as a facilitator that helps you to analyze the data that you have. When I say that as far as the analysis is concerned, it could be done through SPSS, through Smart PLS, through any other platform or other softwares. I'm very much I'm evidently saying that. So what exactly and where exactly we need to work on? So believe me, if there are certain things, when I say certain things, that means some of the techniques, some of the tools. And when I say tools, do not get confused with the softwares. So tools are basically the analytical tools that I'm talking about. So these analytical tools are maybe correlation, regression, the factor analysis that we'll be doing today. Most of the portion from factor analysis, it would be exploratory factor analysis, and some minimal portion that we'll try and cover up from confirmatory factor analysis, because you'll be having another session related with confirmatory factor analysis later on. So the whole set of data will be analyzed from the perspective of multivariable attributes, and this is what exactly we have to see. So with your permission, the coordinators and the host, I'd like to present my screen, and that I have the PPT that I have. May I please?
Yes, sir, please, sure.
Thank you. So I hope you can see the screen that I have right now.
Yes, sir.
So one more thing, I have multiple screens to share, so please do not get confused. Right now, this is one screen that I'd like to share. Then there would be one which is OneNote, on which I'll be doing some kind of scribbling, which is also required. And so I'll be switching between the screens. So do not get confused. And again, I'll be using the software that is SPSS, just to let you know how exactly we can utilize it. I know that the topic that I have been given is use of SPSS for factor analysis. Do not get confused with the title that I have written here, that is factor analysis or multivariate analysis, because factor analysis is a part of multivariate analysis. Before I go any further, I'd like to let you know that there are books available out there, and be the books which are written by Naresh Malhotra and Satyabhushan Das. Maybe the book which is available by Anderson here et al. Book, which is again multi. So all these books are available for research methodology and marketing research, and other titles are there. So you will find analysis as a small portion in those books and in those bounded form of knowledge that we have. So factor analysis is a part of analysis. So my baseline that I have it for today is the multivariate analysis, and how exactly we look at the different the different variables, and how exactly we can go for knowing what factor analysis is. So there are two things that we have. One is the exploratory factor analysis. The other one is the confirmatory factor analysis. My major focus is on exploratory factor analysis today. Starting with data analysis that we have. Sorry. Yes, just hope this pen is working. Yes, good enough. So multiple set of statistical techniques used for analysis of data that contain more than one variable. Now let's suppose we have when we say variables are there, and what do we mean by variables? So you might be from different backgrounds. Somebody would be from psychology, somebody would be from marketing, somebody would be from HR, somebody would be from finance, doing there are people who do research in the field of finance that uses primary data. So now maybe behavioral finance is the area. So these are different areas. So whenever we talk about this multivariate analysis, and then we talk about the complete set of data, there are variables that we have. Let's suppose right now we have we pick it up from the field of marketing. Don't get confused. I know I'll be sharing all the set of examples that I have with me. So suppose I have I want to know that how exactly sales is being affected by maybe the advertisements that are done. And the second thing is the price that I have kept for any of the product, and maybe that there is a third thing we can say that is advertisement price, and suppose the quality of the product. We have the quality of the product. So when we say multivariate, so what exactly is happening? Sales is being predicted by multiple different variables that we have. So one is advertisement, the other one is price, the quality. So the moment you keep on increasing the considerations in your research, somebody is doing marketing, somebody is doing HR, maybe you're looking for somebody's job satisfaction. So the monetize your model that you want to present and that you want to test. This is what exactly we need to look for. So when we when we are working on this aspect, that is multivariate data analysis, first of all, before installing your SPSS on your computers or on your devices, or maybe before you go about taking the data, try to understand what set of variables you have, that all those variables that will be utilized by you in that research. First of all, be sure, have that surety about it, and then you'll be good to go. So in that respect, multivariate analysis is used to study more complex set of data than what univariate analysis methods can handle. So univariate, when we say univariate, so since this is a category advertisement, maybe we can say that sales could be predicted by just advertisement. If advertisement is good enough, for example, Coca-Cola is one company that is mainly dependent on their advertising part, their marketing communication aspect. So on the only thing that they are concerned about, they just go for good set of advertisements, and that helps them to let their sales go up. So there is a direct only one variable that we are considering right now, and this is the variable advertisement. Fine, but many of the times when somebody is selling shoes or somebody is selling mobile phones, in that particular category, one data might not be enough. Must have enough data with us. So the problem will start, and the problem is basically when we say that multiple set of data are there, then it brings complexity. And we know that there are certain statistical tools like correlation, regression. We want to have some mean, median, and mode. All these things are there. So the moment we have multiple variables, our complexity gets to pile up, and we do not get enough of resources, or our mindset could be diverted because of the multiple variables that we are having. So in that particular case, it is very important to use softwares like maybe SPSS, Smart PLS, and SAS. So that helps us to. So these softwares basically help us to do the analysis in a better way. There's before I go any further, there is a consistent noise from outside. Can you please check the host? Yes. So next is why exactly we need to do the multivariate analysis. What is the major importance? So when we say that this is there, one of the major advantage is like it reduces the likelihood of type 1 error. So what exactly is type 1 error? You might be able to get to know in different sessions here. But I'll definitely brief it. Type 1 error are those error that talks that there is a hypothesis that you want to check, and that hypothesis could be anything. That hypothesis could be about knowing whether advertisement is having a good impact on the sales or not. Right. So type 1 error in hypothesis is something that talks about let's say your assumption that you have made, whether that could be true, that could be false. After doing the statistical analysis, the results could be in favor of the hypothesis, it could be against the hypothesis, right? So let's assume that you have and we do not we always take the null hypothesis as those hypotheses which are very much the ideal situation, जहाँ गलती होने की chances ना हो. So that if it is rejected, and even if we are wrong, we do not fall in the trap of having a wrong set of errors. So type 1 error is all about your hypothesis is correct, but somehow you are rejecting that hypothesis. So that means your assumption was right, but the result that you are getting is wrong. So such type of errors are called type 1 error. And when you have multiple level of multiple data, if you have, so multiple variables that if you include in your model, that will help you to reduce the type 1 error. And when we say model, so don't get confused by these are not such heavy things. Suppose I've just given you one example. All are impacting sales. So this is one basic model that you have proposed. and this is just a basic model that you are proposing, and this is what you have to test using different methods. So you don't have to get confused with the thing that whether it will be uh, whether it will work or not, right? So, but sometimes univariate analysis is preferred as multivariate techniques can result in difficulty in predicting the results of the test. So, when we include multiple, variables, the problem is that we might not be able to analyze it properly, and that's why these SPSS and all these softwares help us to analysis in a better way. But the understanding, there are certain assumptions that we have to look for when we see multivariate analysis. And even if we are talking about this factor analysis, we wish to, and we would like to know that how exactly this factor analysis could be checked, and what are the different assumptions that we have. So number one is the normality check, number two is homogeneity, number three is linearity, and number four is the absence of correlated errors. That has to be individually. All the items are very important. When we say normality, one thing that we need to know is there is a normal curve phenomenon that we need to understand, and that is, let's say, all the data that we have, whether that falls in this whether it falls under this. So suppose this is the curve, and we know that this sigmas, that one is minus 3 sigma, 2 sigma, minus sigma. This is the mean zero value. This is sigma, 2 sigma, and this is 3 sigma. So basically, we try to cover up that majority of the data when 90 and plus sigma to minus 3 sigma, we say that one of the condition of normality has been achieved. So there is another thing that is called skewness. Skewness means it should not be suppressed from any one side. There has to be a symmetry between the positive and the negative side. Then there is kurtosis. Kurtosis basically talks about whatever the data that you are having with yourself. That data should not have a peak. That means peak means if this is a central value, the majority of the data should not be aligned towards the central value. There has to be certain kind of variance. So that means if you are able to bring some basic level of variance in your data, then definitely your normality could be achieved. So variance should not be equals to zero, should not be close to zero. It should be somehow very much related. Obviously, the dependency is basically what kind of data set you are having. Whether you are having a data range of 1, 2, 3, 4, 5, whether you are having a data range of 1, 2, 3, 4, or maybe you are having in decimals. It totally depends on you. But the whole characteristics, the whole thing about normality is, the data has to fall under the normality curve. It should come under the 95% of the data should fall under plus minus 3 sigma, 3 times of variance. Agar variance nahi hoga, if the variance is 0, plus 3 sigma or minus 3 sigma will not solve the purpose. So that's why we say there must be a variance in the data. That means kitni bar can I use Hindi as a language in between? Do you have the permission for that? It's just for the ease of understanding.
Yes, sir. Yes, sir. You can use.
Thank you so much. So
Actually,
yes, please.
there are some of the participants who are from South India.
All right, I'll take care of that. I'll take care of that. So thank you so much. So when we say variance, many of the times you have gone with your you might have taken your questionnaire and you have tried to get it filled by the respondents. But what happens that many a times people are just writing 5, 5, 5, 5, 5, or maybe they are taking on 3, 3, 3, 3. So if all the data that you are gathering, everybody is having the same kind of a response, then obviously when you will take mean and you will take standard deviation, you won't be having any kind of a variance in the data. So it is very important to have some certain variance so that your data will fall under the normality curve. And then there is a limit of kurtosis, there is a limit of skewness. If the none of the data would be very much perfect, very much normal. So, but it should achieve normality. This is one important thing. The second thing is that is related with the homoscedasticity. Homoscedasticity. Uh, homoscedasticity is one thing. Homoscedasticity is one thing that we need to when we can say that let me just switch to a screen here. It will help us to understand it better. Now let's suppose I have this graph is there. Suppose there are some set of data. These are my data that I'm having now, and there is data like this. Suppose I have asked one question. The question is basically about this is the scatter plot we are drawing right now. In this scatter plot, suppose I'm talking about these are the number of respondents that we have, all the respondents that are those who are giving us the data. The second thing is basically the values that I'm having. Let's suppose I'm taking a value on Likert scale 1, 2, 3, 4, and 5. Suppose these are the data that I'm having. So when I look at maximum number of people or the respondents that I have, how many number of people have, so if let's say it's 10, it's 20, it's 30, 40, 50, I can see that this is what one has been given by many number of people, that is almost about 30 to 40 number of people. Two has been given by many number of people, and then we take different data. So what happens that in this regard, we see that there is a cluster that is coming up in this scatter plot, right? So this is one cluster. Then I'll see another cluster. Now if I make graph like this of the same thing, and if I this is how I can find out all the scatter plot of all the people who have given their data, their responses on the questions that I have asked. So now I know that there is no set pattern that I'm able to see on any of the data. But let's say that the majority of the data here, and there are nearly 500 to 1000 response. There are almost 500 to 1000 response that I'm getting. So there would be 500 to 1000 number of dots that I'll be getting. So if I'm able to find a cluster that is having maximum data here, or maybe a cluster here. So here the cluster is not clear. I'm not able to make the cluster of responses. So here the cluster is not coming together. But what happens if in the similar manner, if we are able to see, if you are able to see another category of the response, when I see maximum number of people they have been talking, because some number of people they have been talking like this, then we have some number of people they have this kind of a data set that they are saying, then we have this kind of a data set. So now we are able to identify, suppose there are 200 number of people they have given their response on this front. Maybe their answer is related to 2, here it is 3, here it is 4, here it is 5, here it is 1. So here I'm able to connect. This is one cluster, the other one is this cluster, the third one is this cluster. So near about 300 people are here, near about 100 people are here. Total, if we add it up, near about 600 people have responded, but I'm able to make 3 clusters out of it. So this scatter plot lets us know that how exactly we are able to we are able to see that we'd be looking at we'd be looking at a plot, a scatter plot, which will be able to just let us know that how exactly our data looks like. Now if we uh, Now, if we look at it, so we know that we know that this normality thing has been normality thing has been achieved by bringing the data to a normal situation. Homoscedasticity talks about having the same scatter. That means if I have multiple variables, so I have to see whether all the variables are having similar kind of a scatter or not. Whatever scatter plot that I'm seeing, so maybe there is this variable v1 that has this kind of a scatter plot in which all the data are in one format. Then we look at the second variable that again basically looks at the scatter plot, which is giving a similar kind of a scatter. So it is very important to have homoscedasticity in the the data is scattered in a similar way as far as all the variables are concerned. So maybe we talk about the brand value, we talk about the perception of the people, we talk about the mindset of the people. So I'm not saying that if a mindset of two of the people are having a different mindset, or two variables are not coming up together, but that again will that means if this scatter plot is not relating with this, if the relation is not there, that means when we will be able to go and find out correlation between them, the correlation would be very less. And when correlation is less, you cannot bring any kind of a relationship between them, be it regression relationship, be it structural equation relationship, which we are needed to do here after doing the factor analysis, and we'll be going into structure equation modeling. In that, if correlation or the coefficient of correlation is very less, very much close to zero, or maybe very much close to 0.1 or 10%, 20%. So if the correlation is weak, we might not be able to get enough results or good level of results. So this is why this homoscedasticity becomes very important. The next thing is linearity. And linearity is basically when we talk about let's say we say about regression. Regression is something when there is this variable one is regressing on variable 2. This is regression should be a coefficient beta. That means variable 1 is regressing on v2. That means independent variable v1 is impacting v2. So this relationship should be linear in nature. That means if I'm using x or y, the quadratic form or the cubic form should not be there. These things should not be there, and we should be avoiding that. Linearity is one thing that will help us to understand the model very well, right? Even if somehow, somewhere, if we are falling into that trap that linearity is not being achieved, what we maybe there is a curvilinear condition. What we can do, we can use the logarithmic conditions, logs, so that we can make the whole equation into a linear form. So linearity is just a simple thing. There should not be a higher degree of variable that we are taking into consideration. This is linearity. It's just all the points in any variables that we are having, it should fall in a single linear line. The last assumption that we need to follow in multivariate analysis, or maybe in factor analysis, that is the absence of correlated errors. It is basically, let's assume we are talking about sales. We want to increase the value of sales, and that is dependent on price, that is dependent on quality, and that is dependent on advertisement as well. This is what exactly was my previous example. So advertisement is impacting the sales, price is impacting the sales, and quality is impacting the sales. Now what happens, we know that advertisement is a different thing. Advertisement is not related with price that much. Fine, if advertisement is doing, if Coca-Cola or any other company is doing more advertisement, they will increase their price a bit. But there is not much of high correlation. But let's say we know that price and quality somehow are interrelated. If some company is asking for more price, they are bound to give you better quality. So we know that when we will be taking up responses from the perspective of price, whether the price is good enough or not, whether there is a value for money or not, and then we'll be talking about the quality perspective of the product, whatever is being sold, maybe Coca-Cola or anything like that. So what happens, there are certain error terms that are associated with quality. There are certain error terms that are associated with uh, price as well. So since we know that price and quality, these are interrelated terms, they will have some kind of correlation, maybe moderate level of correlation, or maybe they'll be having a high correlation between them, these two variables. Then obviously, when we talk about the errors associated with these two variables, let's say price is there, so price will be having some error. So the respondent, it's not the price that will be having error, it's the data that you are collecting based on price will have some error with itself. The quality will be having the data that you are collecting based on quality, that will be having some kind of a error with itself. The collection of data will have that error. So you should not be having interrelated or correlated errors. So you must have absence of or minimal of, you have to minimize this error. You have to bring that error very less, so that all these, so it's basically the error should be the average of E1 and average of E2, average of E1 and E2. It should not be like E1 is causing error and E2 is causing error. Somehow both are related, so they both will be having a combined effect. So that means, since because of that correlation, we are having some error which is because of both the things, right? So these are correlated errors. So correlated errors should be reduced. So you'll be seeing it in the confirmatory factor analysis, that how exactly we combine two different errors which are correlated with each other. We'll be seeing from that perspective. So just remember this thing, why exactly we need to bring the correlated errors, or we have to reduce the correlated errors, and you'll be good to go. So if the data set does not follow the assumptions, the researcher needs to do some filtration. You might have to, as a researcher, you'll have to work on that front, and you'll have to come up with that. Now we have certain objectives of the multivariate analysis. The one of the major objective that we have is definitely we are talking about factor analysis, and factor analysis is one of the important aspect that we have to do. So when we say factor analysis is what exactly we are here for. So factor analysis will be having two important aspects. One is EFA. FA is factor analysis, exploratory, and this is CFA. So EFA is basically exploratory, and CFA is basically the confirmatory. Now what happens when we say data reduction or a structural simplification is one of the objectives of multivariate analysis. When we go into SPSS, SPSS uses data reduction technique to do factor analysis. So data reduction is something you utilize the most appropriate and the most relevant data out of the complete data set that you have. You reduce certain data, you eliminate some of the data which are not important, you eliminate some of the variables which might not be important, which might be causing some issues because of the linearity, because of the normality, because of homoscedasticity. You get rid of the data, some of the data, some portion of the data, you get rid of it, and finally your objective is to go further with the data. So the very basic one is data reduction. That is one of the important aspects that we have. So just keep a note of that data reduction is one of the important aspect in the multivariate analysis. And again, data reduction is something that is very much related with your factor analysis. We are basically closing down, we are coming down to factor analysis, we'll be understanding that. The second thing is sorting and grouping. This is the second objective that we have to achieve. That means you might have heard that suppose I'm not sure, I have brought down 1, 2, 3, 4, 5, there are 10 or 15 or 20 number of questions that I have. So I have taken, maybe I'm asking the consumers, I'm asking their quality perception, I'm asking about their brand preference, and each and everything. There are 20-25 number of questions are there. I have asked each of the question, but I don't know which question will relate with which. Just as a researcher, I have noted down some of the aspects, but this multivariate analysis will help us to sort which questions, or rather some of the times, do not get confused with the terms like we are asking questions. So these questions will also be known as items, and these items will also be known as specific variables that we are working on. So all those things, when you have collected your data, questions, items, and variables all would be same, so you don't get confused. So if I have asked a question, or if I have anything that if I have set of questions, if I have asked, I have to group it. First of all, group it and then sort it accordingly. Which like out of 5 out of 25 number of questions that I've asked from people, from the respondents, and from the samples that we have. And then what we do, we try to group it up. Let's say I have found 5 different groups. One of the group is asking about the brand preference. The second group is asking about the price ranges. The third one is asking about the quality preference. The fourth one is asking about the next thing. Fifth one is asking. So we have identified and we have checked that in majority of the situation, all the groups are having 5 number of questions each. So now based on that, we are basically sorting and grouping all the things that we have. And this grouping is basically based on the similarity of the objects or the variables. So, these are certain measured characteristics that you analyze. So the data that we have, we provide the command to SPSS, and that helps us to, bifurcate and group how exactly that is being done. But what is the theory behind it? What is the calculation behind it? We'll be looking for that as well. The third objective that we have for multivariate analysis is we investigate of dependence among the variables. That means when we say that investigation of the dependence, that dependence among the variables means how much they are related with each other, and we have to check whether factor analysis won't let you know that which variable is dependent, which variable is independent. It's just you have asked certain number of questions. It's the theory behind the model that you have selected that will be deciding that which variable is dependent on how many variables are dependent on one variable, or how many variables are independent, how many variables are dependent, or maybe some of the variables are moderating or mediating. This is decided by the theory that you propose, along with maybe you do the literature review. Based on that, you propose certain theory. But here, when you collect the data, you do not know how exactly the data are interrelated with each other, and where exactly is the dependency that is coming on. Since we know that there was one thing which was related with price, and there was another thing which was related with quality. So when I talk about these two variables, what happens, and we are trying to get to know what sales are. So we know that quality is something, when you improve the quality, you will demand a better price. So somehow there is a dependence of one variable on another. Somehow quality is being dependent on price as well. But because of our theory, because of the literature that we have studied, we have proposed this thing that price is one independent variable. This is one independent variable number one. This is independent variable number two. So these are two independent variables that we are having. But it will help us to investigate that how exactly different variables are coming together, or how exactly there is a dependency on the variables or not. But again, we have to take care of that. But but it is very important to bring the independence nature all together into all the variables that we have. That helps us to do the analysis in a better way. Because of that, multicollinearity are certain conditions, and the error terms that the fourth topic that we were talking about, that is a part of multicollinearity as well. So the fourth assumptions will not be. So all these assumptions should not be violated. So this dependence, if we are able to understand it, and if we are able to bring it properly in our model, it will help us to understand it better. If you have any query, you can please ask. But
hello, good afternoon, sir.
Yes, good afternoon.
Sir, like in your previous page,
Just a
So
second. There
you
is
mentioned the
just a second.
relation between.
Just a second, please. There is a consistent.
Shubham, kindly mute yourself, please.
Well, thank you. Sorry, I was not able to hear it properly. Yes, please. On this particular slide, I guess.
Yeah. So yeah. So you mentioned this thing कि there is a relation between the sale and
Okay.
price and demand. So here sale is a factor or it's a variable. Like I just wanted to
Okay.
know
Sales is one
like
variable. Sale is
what
one variable.
exactly it
Let's
is.
say. Okay. Sales is one variable
Okay.
that is being dependent on price and that is being
Hmm.
dependent on quality. That means if you if maybe there is a negative impact if you increase the price, the sales might go down. If you increase the quality, the sales might go up, right? So this is how this is independent variable 1, this is independent variable 2, right? So your question was, now can you clarify your question please again?
Yeah. So, sir, I know the meaning of factors. Factors is like कि, okay, factor is I would say the measure term, and price and quality are the variables, and we are studying its impact on the sales, right?
Okay, no. Right now, what you are talking about, there are two kinds of variables.
Like I'm literally
Basically,
very confused between these. Ki what
okay,
sale
just a
is a
second,
factor or
just
a
a second.
variable?
There
Yeah.
are there are two kinds of variables. Number one,
Mm-hmm.
variable is basically the observed ones, right? Observed ones, that is, you ask certain questions, and after that you
Mm-hmm.
record the response. That is the observed one. Then we have the latent form of variables that are basically, you make that latent variable out of multiple observed terms, right? So here I'm not bifurcating anything based on observed one or the latent one. It's just sales is one that I have taken data from, for price is one I have taken data for, and quality is one. All this I'm considering right now as observed. It's like this variable number 3, or the dependent variable, is being impacted by one of the independent variable and the second independent variable. This is what I'm suggesting right now.
Okay.
Are you
So
with
you
me
mean
on
ki
that? Yes.
yeah. So you mean is कि price is related with sales, and sales is also related with quality, and somewhere
Right.
price is also related with quality, right?
Okay, no, just you need to understand that. Okay, I don't want to, confuse you all. Just try to understand, uh, what exactly is happening right now with you. I'm not able to see who exactly is speaking, so I'll just anonymously, I'll be talking because my focus is on my screen itself. Right now, what you're trying to, you're confused because right now you're trying to look at all the variables as whether you want to understand whether it is a dependent, this is an observed variable, whether you have taken data or not. It's just, variables will never define what exactly is the outcome, what is the exactly the final outcome in the market. What I'm trying to make you understand is, just try to understand this thing, the real scenario. We are the researchers, we try to analyze the real scenarios and we try to bring it in the form of thesis and research papers, right? So the real scenario is, there is a company, maybe Coca-Cola, maybe Cadbury, or any other company, they are trying to increase their sales. Their agenda is to increase sales. We researchers are trying to find out what are the variables they are impacting. This is it. This is the very basic thing I'm trying to tell you. So there is, as far as the whole set of observed and latent variable types, I'll be considering it at a later stage. Right? Am I clear right now? So there is no form of, I have not brought anything that is basically describing the types of variable or anything like that. I'm just trying to relate to you with the reality that we have in the market. Are we good on that? Shall we move ahead?
Yeah, sure. Thank you.
Okay. This dependency, all right, coming back to the point that you were saying, that there is independent variable one, just forget, or just let me write, price is there or quality is there. So what I'm trying to say here is, when we are talking about sales here, so these are the two variables we have taken. Our model is saying this only. These are the two variables that is impacting sales. Now we know that there is some kind of, association between price and quality. This price is saying when you increase the price, there will be a decrease in sales. If you increase the quality, there will be increase in sales. Both the things are impacting in a opposite direction. So there is a price increase and sale decrease, that is, there is a negative kind of a impact on sales. And here the impact is positive. You improve quality, sales will improve. But since we know that, if if you are giving good quality, the if the company is giving good quality, they will ask for a better price, more price. So there is a kind of connection between price and quality, which is right now not our concern. But the point is, when we will take some true data from the responses, from the respondents, they will be providing you the data, and somehow this relationship is going to be there. So this will be a kind of, this is what exactly we have to avoid. We do not want such variables amongst us, which will be which will be relating to each other. Now, for example, let's say we all are, in the field of research and academicians. We mostly will be, we deal with the students that we are having in the class. If I want to have a different set of opinion from everybody in the classroom, and if two people are behaving in the very same manner, those two people are the toppers of the class, they have very similar kind of answers or something like that. So if you want to, include the experience of each and every student, suppose there are 40 students, out of which you are taking inputs from each and every student. So student 1 is giving his response, student 2 is giving her response, student 3 is giving his response, something like that. But when we know that student 2 and student 3, they are the toppers of the class and they say the exact same thing. So as far as the contribution in the class is concerned, they will be having a very similar kind of contribution. Would you like to repeat their opinion in the class? Obviously, it's a waste of time. So this is what exactly I'm trying to convey, that we can take the variables which are correlated, but the that multicollinearity must not be there. The price should not be like, suppose I'm saying quality is good enough, and then again I include one, that is brand value. So we know that any product having good quality will have a good brand value in majority of the situation, right? So these two are highly correlated terms. If we include it in the model, then definitely it will bring some kind of multicollinearity. I'm not saying that you cannot include multiple variables. We are very much open for bringing many of the variables in one study. But the point is, if you are having enough variables in your in one model, what happens? The chances of multicollinearity keeps on increasing, but you have to control it. Right now, if we just take up one or two or three variables, one or two or three independent variables, the chances of multicollinearity would be less. The moment you keep increasing the number of variables, the chances of multicollinearity would be quite high. So we have to consider that as well, and we have to bring multicollinearity down. This was my implication from that point. So as far as the dependence part is concerned, this multicollinearity, this dependence, this is what exactly I have been talking about. Try to investigate about the dependence and try to understand whether all the variables are mutually independent to each other or not. If it is there, it is very good. So try to bring that. So all the points that I have said right now, and this point number 3, we basically want to, all these things coming together are trying to say that there must be number of variables having least of multicollinearity, least of correlated errors, so that every individual variables will be having their great impact on the dependent variable, right? So if many of you might be in a very beginning stage of your research, so I'd suggest them, if you're going to if you are developing your model right now, if you're trying to find out description and explanation regarding that, definitely keep this into consideration. Do not bring very closely related variables together in the study. That will definitely is going to impact, that will bring this multicollinearity aspect into the picture. That might bring some troubles for you as well. But that's not a big issue. You can always get rid of it. You must have enough number of variables and enough data. You can definitely reduce at a later stage. Next thing is prediction. The prediction relationship between the variables. Prediction is, this is independent variable. Then we have a dependent variable. So there is an impact of independent variable on the dependent variable. So that means independent variable is predictor. And this is the dependent variable that is being predicted. So this is just a simple thing. Prediction relationship between the variables must be there. That means one variable should be impacting the other one, must be determined for the purpose of predicting the values of one or more variable based on observation. So right now, if we have only one independent variable, we might have multiple. So there will be 1, 2, 3, 4 on, and then we can also include the number of dependent variable as 1 and 2 and 3. So if we have one dependent variable, we can use regression. If we have multiple, we have to go for a structural model. One last thing related to the objective of multivariate analysis is the construction of hypothesis. This is one of the major, one of the most important thing that you must have a very clean set of hypothesis for your model. You might be confused at some point of time that what will be the hypothesis, how exactly to write a better hypothesis, or whether the hypothesis is correct or not. You work on your model, try to make your model perfect with best set of explanations from the literature available. And then as far as hypothesis is concerned, taking in basic research hypothesis or changing it into null and alternate hypothesis, that is not a big problem. Anybody with having a basis of basic experience into research will be able to help you with framing the hypothesis. So that's not a big problem. But yes, this is one of the important things. So if you focus on your model, if you have your proposed model will lead you to understand the objectives as well as your hypothesis of the research. So that is not a big problem for that, and hypothesis both. But this is one thing, that this may be done to validate the assumptions or to reinforce prior convictions that you are having. So it's just when you are assuming anything, you have to take a side, whether this is true or whether that is true. You prepare your hypothesis based on that, and then you come up with the final testing. And then once you decide about what kind of hypothesis you are selecting, based on that, you'll be able to test it as well. One of the major advantages that we have in multivariate analysis or factor analysis is that it considers more than one factor of independent variable. So there are there is not just one factor that we are talking about. There is not just one variable that we are talking about. We can talk about multiple factors at a time, and then that influence the variability of the dependent variable. So dependent variable is one thing which is not just impacted by one. It is impacted by multiple number of independent variables. So in that regard, if you keep including the independent variable, if you keep including the number of independent variable, it will bring more accuracy. You might have heard about, there is one important thing that we always talk about, that is called model fit, which is described by R square. R square is something that is usually seen in regression. So what happens that if you keep including the number of variables, your R square will keep on increasing. And this is all about model fit. That is a different thing, that we should follow the adjusted R square thing. That is a different explanation. But at least this R square will be improvised. So, but my suggestion to you is, do not fall in this trap that you are having. You can test a model with the 5 or 6 or 7 number of variables, or the number of factors that we have. Do not go into much depth. Do not pick up complex models in which you are having 12 to 13 or 15 number of factors and you are testing it like anything. Just whenever you're going for a primary survey, if it is a very basic form of research that you are doing, if you have just started, my suggestion to you is you do not go for multiple number of questions. Just ask 20 to 40 questions in your questionnaire, not more than that, because the respondent will be bored. And try to have total number of variables or factors. If we say the total number of factors should be 5, maximum 6. Don't go beyond that. Once you keep increasing, you keep on increasing the number of factors, the complexity increases, and along with the complexity there are so many problems that comes along. So, for having a better model fit maybe, or having a better R square, you can definitely include, but try to have a proper explanation from the available literature that you have from different, good researchers. And another advantage is the conclusions are more realistic and nearer to the real life situation. This is what I was saying. If I'm picking up anything from the market, if I'm doing a brand survey, if I'm doing a product survey, if I'm doing a survey for sales, if I'm doing a survey for job satisfaction, and if I'm doing a survey for work-life balance, maybe I'm doing a survey for psychological well-being of the people. So everything, as a researcher, we have to give good results. Not good results in the sense that everything has to be positive enough. Good results in the form of good statistical results and good interpretation and good conclusion and good recommendations. This is our duty as a researcher. So we must focus on the realistic aspect, bring the model from the realistic situation, test the model, and then finally give your results for the realistic situation itself. And this is what exactly brings the chances of having your research paper being published in the good journals. So try to be very much realistic. Don't bring anything extra, anything complex, anything that will bring complexity to your research model. Just try to be very much simplistic in nature, and we are very much realistic in nature. There are certain disadvantages as well of multivariate analysis. When we talk about the disadvantage, the very basic disadvantage of multivariate analysis includes that it requires more complex computations. But when we talk about these complex computations, we know that that's why we are taking a help of an aid like SPSS. So this complex computation could be done in a simple snap, but we must know that what exactly is happening in the background. And then many observations for a large number of variables need to be collected and tabulated. It is rather time-consuming process. But obviously, if a model is there in which large number of variables are there, maybe 5 to 7 or maybe up to 10, good enough. We just have to control the variables in such a way so that we do not go into the wrong direction. If we are able to control 3 or 4, then we can go for 5 or 6. If you are able to control 5 and 6 number of variables in the next research paper, in the next form of research, we can go for 8 or 9 or 10. So this is how we can increase the complexity, and we can do we can do the research in the similar manner. But try to start your research from the very basic one with limited number of variables, maybe or limited number of factors. Now, before I go any further, I'd like to clarify one thing here. There are two terms that I have been using synonymously and interchangeably. One is the variable, the other one is the construct or the factor. Now let me just tell you how exactly these terms are different. So if you have asked multiple number of questions from your respondents, maybe question number 1, 2, 3, 4, and you have said that there might be some areas that you want to cover. Let's say there is one factor, there is factor 1, factor 2, factor 3, factor 5. We can say that question number 1, question number 2, question number 3 up to question number 5, they are falling in one factor. Factor means maybe sales. I'm talking about sales right now. This factor 1 talks about sales. I'm asking multiple questions on that. Factor 2 is basically I'm talking from the perspective of question number 6 to question number 10. Factor 3, question number 11 to question number 15. This is how I'm having all the questions. So suppose this is sales. The second factor is about price. So I have been asking so many questions, but in which I'm asking multiple questions related to one factor. So this is how these number of questions or these number of variable will lead to make one factor. So these are the observed variables, anything which will be in the form of squares. These will be one factor that you will be observing based on the question, and this will be the factor, or rather this will be v1 or v2. It will be question, it will be variable, it will be item. So these are the same things: variable, questions, or maybe item. So all these things, factor or construct will be one thing which is basically latent. This factor is being made by or is being developed by first variable or first question, second question, third, fourth, and fifth, like that. So this is where we have to bifurcate that construct is different or factor is different from the variable that we are having. Variable means every time we'll be talking about the observed variable, the observed data that we have from the questionnaire. Now, when we talk about this classification of multivariate technique, there are so many things that we have to, understand here. The very basic one is, first of all, you need to understand the very basic difference from the perspective of how many number of dependent variables you have. So if you have zero number of dependent variables, then there are different attributes that you have to see. If you have one or more, or maybe any positive number of or any integral number of dependent variables, then there are different techniques that we can have in multivariate techniques. So if we have dependence techniques, dependent variables, we have metric, non-metric and metric data. Nominal data and ordinal data are usually the non-metric data. If you are having the nominal data, the discriminant analysis is one thing that we can always work with, conjoint analysis and logistic regression that we can work with. As far as the ordinal data is concerned, we can go with the Spearman's correlation. Then we have another type of a correlation that is called Pearson correlation as well as there. But with ordinal data, Spearman correlation is the better one to have. Then we have metric data on which we have taken response from interval and ratio. And this we have correlation analysis that we can go with, some bivariate, some multiple regression analysis that we can go with. ANOVA and MANOVA we can go with, conjoint analysis and canonical analysis that we can go with. But right now we are more focused on these aspects. Why? Because factor analysis is the one that we are concerned about. And here interdependence technique is used. Basically, initially we do not categorize whenever we have got the data, we do not categorize it based on the dependence nature or the independent nature. Dependent, it could be dependent, it could be independent, we are not at all concerned about that. Right now it's the whole set of data that we have, maybe for 25 number of questions or 25 number of variables that we have. We just want to analyze it from the basis of factors, how many factors that we are able to develop. So from your research, from your model, that how exactly your data would be working, whether there is a dependency or not. But right now you are not concerned about that. The whole set of data is there is no dependency or independency. You just have to consider that these are simple data that you are having, and you will go on with the factor analysis. Once you have factorized it, you have explored the factors and you have confirmed. There are two techniques of factor analysis: exploratory and confirmatory. Once you have explored the factors and once you have confirmed what factors that you have created, after that you can decide about whether your factors are dependent or independent. Then you can run the regression equation, or you can run the structural equation on that particular front. But right now, when you will pick up the data, it's totally the simple way of data in which you are just trying to identify the factors. So there are various tools and techniques that you can definitely apply on that. This is what exactly I was telling about. It's correlation that you can check. It's the regression that you can check. Factor analysis that we'll be doing, because right now there is no set of dependency, and we are basically saying irrespective of dependency, whether dependency is there or not. We're just following our factor analysis method. That's it. I have correlation with me. I have regression as well. We'll be talking about that. We can go with the regression analysis, but we'll directly move on to the exploratory factor analysis part. So we'll skip this and we can go on with the same thing. So right now I'll just move on to the SPSS file that I have. Um, mm, Okay, this is one set of data that I want to bring to you. That this data was collected. This is a sample data that I have taken from SIA, and that I want to utilize it for the purpose of briefing you about to see. Just check that what exactly these terms mean to us. This is the ID. ID, that means we have enough number of respondents that have given their data right now. So every assigned one specific ID. So right now, if I have to see, I have 520 responses that are with me. So this is ID, and this is different factors that I have. So you can MSS1 to this one set of data. This WLB1, 2, 3, 5. This is one kind of a data. But exactly, you are trying to understand that these are the data that we have, which I have already grouped based on because I know what kind of questions I have asked, but I don't know whether they will fall under the same condition or not, they will fall under the same groups or not. But if it falls, although I followed a theory, I took up some standard questions, and then I start to do certain tests and analysis. Based on that, I was able to understand whether my data was good enough or not. So this is the data set that I have, on which we have, later on we have experience, marital status, profession, children, designation, and organization. These are certain something which is related with the demographics. Now, this is the data that I have collected on my Excel sheet. Now I want to bring it to my SPSS. How exactly SPSS looks like. So when I have opened it up, but right now what I'll do, I have just opened up SPSS, and I'll open a new file from here. I hope you all are able to see the screen that I have right now with me.
Yes, sir.
Good.
Yes,
So,
sir, it is with me.
all right. Now, this is something right now. This SPSS is maybe the version is 25, but this I'm using on my Mac. You might be having a different kind of a thing. The softwares that are installed on Windows device or a Mac device, that could be different. So right now I'm using a Mac. That's why the whole set of, maybe you'd be finding something which is different. So now I want to take up data or open data. Uh, Sorry, I'll do it again so that you can file, new data, or open data, because I have already a data that I'm having in a Excel format. So I'll just open data. Once I open data, it asks me what kind of a data that I'm utilizing. So I'll just, first of all, I have to select it. I'll go to the desktop where I've saved my, file or the folder that I am having. It is taking a bit of time because there are so many softwares that I have used. I'm using a pen tab, so that is again taking some of the space. I don't know why exactly it is taking a lot of time. Now searching about data. Well, sorry for this delay. It was not expected to take that much long.
Excuse me, Dr.
Yeah,
Arif.
yes, please. Yes, please.
I just want to know how you get the name of the columns.
Okay, fine. I'll explain that right
Okay.
now. Let me just. Okay, first of all, let me just tell you that this this window of this SPSS, basically SPSS, the full form of SPSS earlier was a statistical package for social sciences. When it was purchased by IBM, now you can see here this name is IBM SPSS Statistics Processor is ready. It is written down here. So SPSS was later purchased by IBM. Maybe the version 17th or 18th was purchased, and from that time onwards, IBM is giving International Business Machine is the name of the company. They are giving this particular as SPSS, and the full form has been changed. It's called Statistical Products and Service Solutions. So it is very much similar to the dataset that we have from that we get from Excel. So there are two views that we get. One is the data view. Right now, the data view has been highlighted, where we'll be able to have different cells. It is just like Excel. It will just work like Excel. It's just the rows are given by 1, 2, 3, 4, 5, 6 in Excel, and the in Excel here it is written var means variable, that the variable that you are having. Then there is a variable view. Here the variable you can create your own variable. Suppose if I write a variable as uh, uh, name. If I'm writing name, and the moment I click enter, I'll be seeing that there is a variable name with the name. Maybe I'm writing a name or ID of the people. It is a numeric type, or I can change it to some string, or rather, let me just change the name to ID rather than having. I'm changing it to ID. So this ID is basically I'm giving numeric numbers. Decimal I'm not requiring, so I'll keep decimal as 0. The width is 8. That means 8 digits, up to 8 digits I can include. Label I can write, or maybe I cannot write it. It's totally up to me. It's the identification of the people that I'm having. Then the values, right now this value doesn't mean anything here, so I'll be talking about values later on, missing later on. Columns later on, align. Measure is important. What kind of a scale you are measuring on? So we know that ID is something that is very much unique in nature, and these numbers do not mean anything. If I'm giving ID to one to myself, to maybe Dr. Jamshed, to ID, I'm giving ID 2, maybe Dr. Asad, I'm giving ID 3, maybe any other person I'm giving ID 4. These are the individual names that I'm giving. So the nominal scaling would be there. I'll be putting up nominal. So the moment I define the whole set of variables here, I'd be able to see in the data view that there is one column that has been created with the name ID. Now I have 1, 2, 3, 4. All the people who would be responding to me will be written here. Now similarly, if I want to include another variable here, let's say I was talking about sales, I was talking about price, I was talking about quality, I was also talking about brand value. So since brand value is there is a space, there is no provision of a space that you can have in the name of the variable. So here this brand value should be without any space. So I have written BRND VAL. So it is basically brand value. Here on the label I can define, I'm talking about the brand value thing. Now I can take it, I'm measuring it on some scale, and I'm after measuring I'm bringing it here. So I will give the type as the scale. Now this is how exactly it will be defined, and this is how the data will look like. Now what somebody has said, now I have to codify it. I cannot write strings. The numbers are important for me. Maybe on sales I'm talking about whether the sales is good enough or not. Somebody is saying it is quite good enough, they're giving 4. Somebody is saying 5 is quite more than good. Somebody is saying it's very much neutral. I have defined it as 3 is neutral. Somebody is saying it's not that good. It's 2. So these are the numbers that I'm coming with. Now what happens that if you want to define these numbers well, what you can do is you can go to the values aspect. Now we know that there are 5 different values I'm taking. Value number 1 has a label that says uh, uh, not, the sales are very bad. This is what I'm saying. I'm adding it. The second value is basically sales are bad. Third one is sales are that means okay. Number 4 is sales are good. Number 5 means sales are very good. Now, this is how exactly I have defined everything. I've given different values. 1 means something, 2 means something, 3 means something. Now I have defined it. So now whenever I'll click here, I'll be able to see what are the different set of values that I'm having. And similarly, I can give values to these, and these. And we know that the same kind of a thing are there. So I'll just copy it. I'll just here, I'll just copy it from here. Copy. And then, I have to shift and select, and then you have to paste it. Paste. All the similar values would be pasted. Now you can decrease the decimal values because you know that there are no meaning of the decimal here. You can decrease the decimal value and you are good to go. Now if you look at the values, you'll be seeing 1, 2, 3, 4, 5. This is how exactly you define it. And now these are the values. So someone would be writing 3, someone would be writing 2, someone would be writing 3 again, someone would be writing 4. So it will be from the perspective. So this ID was mine. I'm saying sales was good, price was so, quality was also good, brand value was very much good, very good. Then Dr. Jamshed is saying sales was very good, price is not so good, that is bad, quality is so, and brand value good. So this is how exactly I'm writing that. I'm putting down all the information here in different senses. So this is how my data set would be created. But if you have already created a data set using with the help of Excel, it's better you create your data set with the help of Excel, and then we can import, data, or yes, we can import data from Excel that we can have from stop. Okay, this is creating a lot of trouble. Let me just I'm opening a new data set here. Now, what I'll do, I'll come here. I'll just these particular values here. Let me just check. I'm not taking the topmost values because these are my name of the variables. So I'll be, mentioning those names in a and then here. Yes, and now I'll be pasting it on untitled 3. This is the newest one. So I'm just pasting it here, Control V. Well, there is a very easy method to import the Excel file into SPSS, but because it is not happening right now, so it's I'm not able to do it. Now you can see that every data is here. It's just the 2 decimal places. I just have to define my variable here. So the very first variable that I'm having is, I'll keep the pen down. It was ID. The second one was just one, two. Okay, let me just do one thing. I'll Control C. I'll paste it here. Transpose. Now copy and I'm changing it here, so all the variables would be changed, hopefully. An illegal character. Let me just check. Okay, how come? ID. Professional scheduling, design and implementation. And I'm copying it and I'm taking it to it's ID analysis. Okay, just let it be. I'm writing few of the things here. Let's say this is variable 1. This is variable 2. Now this is variable 3. This is variable 4. This is variable 5. This is variable 6. This is variable 7. This is variable number 8. You all can see that I'm defining each and everything, all the variables, and this is variable number 9, sorry, 10. Variable number 11, 12, variable number 13, variable number 14, variable number 15, variable number 16, variable number 17. Let me check from here how many do we have. 1, 2, 3. So JS is 20. Variable number 18, variable number 19, variable number 20, and then we have experience, marital status, profession, we have experience, we have marital status, we have profession, then we have number of children, designation and organization. Child underscore number and designation. I don't know, there might be an issue with because we do not have any extra data that we are having right now. So okay, it's just a second. This variable is basically your experience. And this is your marital status. And this one is about profession. This is about your number of children, and this is about designation. I know it's design, but fine. And the last is the type of organization that we have. Now here what you can see is right now we are able to see the whole data in this particular format. We have defined all the variables. Now what exactly is the problem here? You might have seen that I did not write exp exactly, and I have written exp1. Why exactly this is here? Because you cannot keep the name of two variables same. That's why you have to do it, and you have to, every variable will have a different name that you are having. So here what I am doing is that first of all, reduce the decimal numbers. I don't want the decimal numbers. I want all the decimal numbers to be 0. All these are numerical values. I have codify it. No, right now I'm not concerned about rest of it, because these are the variables that I'm concerned about. Starting here, V1 to V19, these are the data that I'm concerned about right now. Now, as far as values are concerned, all the values were taken on a Likert scale. Value, it means strongly disagree. Number 2 is about disagree. Number 3 is about neutral. Number 4 is about agree. And number 5 is about strongly agree. So these are the values that I'm giving. So please remember these things, what exactly I'm trying to say. So this is the values that I have presented here. Control C, select from here until variable number 19, Control V. So now I'll be able to have the same thing. I have decimal 0, and what you can do is ID is basically same. Rest of the skills, we know that this Likert skill is a ordinal scale, but right now since we know that there is no dependency or something like that, we know that there are 5 intervals that we have created, and we sure we are not about it, we are not knowing it, but right now we can keep it as a scale variable and we can carry on with that. Right now we are not falling into that debate of whether it is a Likert scale is a ordinal scale or a interval scale. We know that it's majority of the times, and 95% of the times it's ordinal scale, but it's like currently our major focus is to do the basic factor analysis. Now, my first question to all of you is, now I have the whole set of data. Let's just save it right in desktop. Okay, I don't know. I'm saving it as data set. This is of this sav.sav. I'll just save it. So now you can see that this has been changed as dataset factor. As very basic test that we want to have is, so this is a button that talks about all the recent tests that you have performed. But if you really want to perform any test here, what you can do is you can go to analyze. One of the important thing that first of all we want to check is whether the scale that we have selected, whether this is reliable or not. So my basic thing that I want to tell you is that first reliability. Right now ID is not important, it's just the tested. This is 19. This is the testing block basically. So now whatever here, and this is the testing block, you can apply all the tests. So on statistics, it's just the alpha value that you want to check, descriptive of the items, rest of the things you do not require. It's just the alpha value that you want to check, and that we call it Cronbach alpha. That is basically the reliability. The moment we hit OK, this is the very basic test that we are applying right now, that will be talking about what kind of results that we are getting. So this is one of document 1. This is the logs that we are having. It talks about all the, this block is basically the syntax that talks about what kind of data set, what kind of command you have given to it. And finally we can see that this is the reliability statistics. This is the case processing summary. That means there are 522 responses. None of them has been included. Every of the data has been included here. Total number of 522, and finally the Cronbach alpha value of 19. Why we are considering these 19 only? Because these were the questions that we have asked from the people as far as their demographic data, that what is their experience and what is their different set of the things. Right now we are not concerned about that. These are the basic questions. We want to know about all the important factors and the variables that we have asked the people, and the Cronbach alpha value is 0.895, which is very much near to 0.9. That is 89.5% is the reliability of this particular data that we are having, all the 19 variables that we are having right now. Now we can close it. It will pop up again. Time that data with us. Look at this particular view, or maybe you just look at this output 1. You do any kind of analysis that you want to do from here. Everything will be very much same, right? So now I want to apply the factor analysis here. So for doing the factor analysis, you have to go to analyze. Can I ask this question to everyone out here, that what are the basic objectives? We have seen different objectives. Out of 5 objectives, we have one objective of dimension reduction. We reduce the data, we reduce the dimension. Right? I hope you agree to this. Out of those 5, we were having an objective of dimension reduction.
Yes, sir.
So here, this dimension reduction is one of our important criteria, and this analyze, dimension reduction, and factor. This is what exactly we have to pick it up. So this you can see, and there are so many other tabs that that are there, but right now we are concerned about that. So with dimension reduction and factor, just click on factor. After clicking, we'll be seeing the same kind of a window. This is the test window that we are having. So these are the variables that hit shift or press shift arrow. With using the arrow, you can select all the important variables. So I'm selecting to test. After doing this particular testing, we are going for And on this right, there are so many things that we are talking about. Now I'll be explaining one by one what are the important things that we have to do. So the very first one is descriptive. Descriptive, you might be knowing that there are descriptive statistics that we talk about. Descriptive, where we get to know the better version of description about the data that we are having, or whatever the data. Suppose taken the score of, let's say, research methodology, one subject that I'm teaching to my students. I've taken the score of research methodology of all the 40 students who are present in my class, right? So descriptive is basically all the data that I'm having, the descriptive, although there are so many things: coefficients, inverse, reproduce, significance level. One thing that we have to check, that is KMO. KMO, full form of KMO is Kaiser
Mayor octane test.
Mayer of this talks about the sampling adequacy. So when we say sampling adequacy, that means how good your sample is for doing this kind of a factor analysis test. Going back here, so I'm just selecting KMO. In statistics, we have initial solution and univariate descriptors. I'll be explaining through the output window. So right now I'm selecting that, continue. Now we have extraction. Now, what is the meaning of extraction first of all? When we say extraction, there are various methods of extraction. We have principal component, we have maximum likelihood, we have image factoring or alpha factoring, all these are there, but we can focus on the principal component analysis method and maximum likelihood. What is the significance? I'll be telling you. There is another thing that is called eigenvalue. This is also what we are concerned about. Let me just explain these two for you, and then we can move on. This was the KMO value. KMO is basically, we have known KMO, we wanted to check. It's about the sampling adequacy. When we talk about the extraction method, extraction is something right now, this extraction could be very well understood using the Excel sheet. When you try to extract the factors. Right now, what you're doing, out of all the 17 items that you are having, 17 items or 17 variables you are having, which you want to bring or extract few factors. We know that there are 17 items, but how many factors will be made out of these 17, we are not sure. So for that, we are having two different extraction method. One of them is your principal component analysis method. The second one is your maximum likelihood. Principal component, and this is your maximum likelihood. Now going deeper into it to all the purpose, so I'll just explain to you in a very simplest manner. Maximum likelihood is is one thing. Suppose you are having you ask all your students, all the 40 students of your class, to stand together. Now you want to understand and analyze what kind of personality do they have. When we talk about personality, that means how they look, how are they behaving, what is their nature, and everything you talk about. Means who's good with the studies, who's good with speaking, who's good with as far as nature is concerned, who uses good language and who uses better communication skills, who is good at communication skill, who is good at analytical skills. This is what you're trying to know. Since we know that when we talk about the personality of my students, what I can do, I can divide some of the condition. So I'll try to extract certain number of groups of students. So I know that when all the good looking students who are showing good looking and they are wearing good clothes, they are having good outlook that I can perceive, they will be that I'll ask them to stand together. Now, what I'll do, I'll ask some of the students who are good in studies to stand in one group. Then I'll ask all the students who are well behaved to stand in one group, right? And then I'll be asking a few students who will be good, having good analytical skills to be standing on one side. So this way, I'll be able to group all the students in different conditions. But here, what is the situation that I know that one student could be good looking, the same student could be along with good looking, he or she might be very well or very good with studies. That particular student could be good enough with the analytical skills. So where exactly I have to put him, or where exactly I have to putting him in or her? So it's like, which of the aspect is having the most weightage? His looks are so good that I don't want to see his studies or his other performance or analytical skills. So based on that maximum likelihood of that personality, I'll put him in that particular group, or rather I'll put her in that particular group. This is one way of understanding how exactly you are segregating or you are sorting or you are grouping all the variables or all the items that you are having. Principal component analysis talks about this is the maximum likelihood where exactly that will deem fit. Principal component is about, we know that there are certain traits that we are having. Principal component helps us to identify all the major factors, and it talks about the principal components that will be playing the role, and everywhere certain percentages would be put. In maximum likelihood, I'm asking that particular component, although there would be certain traces of the personalities that I'll be able to see. In principal component analysis, I'll be focused on the principal aspects of the different attributes, and then I'll be sorting on that particular respect. So although maximum likelihood or principal component, use it any method, your grouping of the variables would be very much similar to each other. It's just the way you group it. There will be a difference. There might be a difference in the way of picking the students. But suppose I'm picking principal component and somebody else, maybe XYZ person, or maybe Dr. Jamshed is there and he's picking maximum likelihood approach. So we both will be grouping the same students in different groups. But there might be a possibility, and it will be very much evident, that the group that I will create, the total number of groups that I will create, and total number of groups that he will create could be similar to each other. It's just the difference. Now here we have to use this principal components analysis. As far as this extraction is concerned, what you do, extraction is something about iterations. Iterations means how many times you are rotating the values. Let's say there are 17 different variables that I'm having. I will pivot one of the variables and I'll rotate rest of. I'll compare variable 2, 3 up to variable number 19 with variable 1. I'll compare one by one. So first I'm fixing V1 and I'm rotating each of the other variables with V1 and I'm comparing it. So time and again, so when V1 will be compared with the rest of the other variables, that will be one iteration. Then I'll be picking up V2, then again I'll be taking up, comparing it. So this is what exactly software help us to do it in a much faster rate. I can compare each and every variable with each other, and based on that, the total number of iterations that I want to go is 25 numbers, and based on that, we'll be able to see what are the results that we are getting. Eigenvalue is something, that right now you can understand it from the perspective of the weight that is being given to the factors. So either you decide that I'm having exactly 6 number of factors. Maybe I don't know. Maybe I'll be getting 6 number of factors. I'll be getting 7. I'm not sure about that. But what I'm trying to do here is I'm trying I'm trying to give the weightage to my variables as any factor which is having eigenvalue greater than 1 will only be considered as factor. Anything extra, we that talks about the worth of a factor, that how much worth that has which you are giving importance to each and every factor, each and every variable. So we will keep eigenvalues, the lowest value of eigenvalue is 1. Do not bring anything below 1 right now. We can write 0.9 as well, but we don't want that. We will keep the minimal eigenvalue to be 1. Continue. Rotation, since we are talking about the iteration and the rotation, it's the varimax rotation that we have to follow. That is, there are so many other methods, quatimax, equomax, promax. It's just how exactly you are rotating. This is one way. Which one you are selecting as a pipe and you are doing it. So total number of for convergence is 25 again. I'll be explaining it when we'll have enough time. But right now, this is the thing that we are concerned right now. We'll be talking about in a general context later on. We are very much limited with time. Then we have scores. Right now we can just skip it. Options. I'll run the same thing again with this last thing.
भाई मैं अपनी
Mr. Muhammad Azhar, please mute yourself.
Now this is the factor analysis that we have got. In this, we have title, that is factor analysis. We have notes. This is the notes. Sorry, exactly the notes. Notes right now we are not seeing. KMO and Bartlett test. Notes may, if you get any kind of an error, that is provided in the notes. KMO and Bartlett test of sphericity. That is whether your sample is adequate or not, and we are getting 0.902. That means our if anything it is better than 0.6, 0.7, this KMO value is good enough. When it is saying it is more than 90%, more than 0.9, that is your KMO value is good enough. Means your sample is good enough. And obviously I have taken 522 responses. That means I have enough number of samples. This is communalities. So communalities and the value of extraction, what exactly does that mean? Initially, when you have kept all these things into one system, you know that the very basic input one, like the variable 1 or variable 2, we consider it as 1. The value that it possesses with itself as 1, unless it was part of this complete grouping, this factor analysis. But when we have used it in the system of factor analysis, I can see the role that V1, V2 and all the other variables are playing. It is 0.562, 0.634. These are the extractions that we are getting. So anything which is above 0.5, that means at least the worth after the extraction, the worth of the variables left out is greater than 50%. We can take that particular variable into consideration for a later phase. So since we know that all the values of extraction in the communalities all are greater than 0.5, so we will consider all the variables into the picture, and we will consider each and every variable. So we have 0.5, 0.5, 0.5, 0.5, 0.5. So these are the certain values. So like V7, the lowest one is V6. Then we have I guess V3 and V7. These are having the lowest value. Rest of it are above 55%. So these are the weakest values. If you want to delete anything, if you want to reduce out of our data, or dimension reduction if you want to do, we can reduce these values. So just remember this thing. This V3 is something that is having least value, or the least value is V6. Then we are having V3, and then we are having V7. So V6 is having the least one. Now going to the next one, that is total variance explained. So here, this is the eigenvalues that we are getting. First factor or component or construct, the eigenvalue is 6.9. The second factor that we are getting, so up with this we are able to see that 1, 2, 3 and 4, and here it is completed. So all the components that we have been talking about component. So the principal component with common qualities have been identified, and they are 4. All the components are having greater than one eigenvalue. That means their weight is greater than 1. Now, when we look at other components, so principal component analysis was able to identify 5th, 6th, 7th up to 19th. यानी हर variable अपने आप में, every variable was a component in it. But as far as other variables are concerned, one of the component was has been 0.87. Eigenvalue is less than 1. The other one is 0.691. Other one is 0.640. So we are not considering other components. We are just considering those components which are having eigenvalues greater than 1. I hope now you are able to connect with that. Now, one more thing that we are concerned about right now is this value. We call it total variance explained, and that is 64.662%. That means all the 19 variables coming under 4 different factors with greater than 1 eigenvalues are explaining the total variance as 64.662. 64.662%. That means, and the reference value is 60%. If your total variance explained is more than 60%, you can consider that. Had it not been exactly 60% or less than, had it been less than 60%, you could have reduced, variable 6 because the value was very less. So this is how exactly, and reference value is 64%. This is the variance that is being explained by each of the factor. So the very first factor is explaining a variance of 22%. The second factor is explaining a variance of 15. Third one is explaining a variance of 14. And the fourth one is explaining a variance of 12. When we combine it all together, the whole is 64%. This is the cumulative values. So, so this one is also good. We have to, come up with a better result. Component matrix this is the critical component. These are the principal components that have been framed here. Number 1, number 2, number 3, number 4. But we are not concerned about the very first component that has been created. We basically want to go to the rotated component matrix, the last component, the last rotation that we look at. After the 5 iterations, this software was able to bring this kind of a system. Now we can see that in the very first one, I can see the values or the loadings are given. We know that these variable number 10, 11, 12, 13, 14, 15, all these are having large loadings. This is what exactly we have to consider. We have to check. But I know that looking all together at one point of time is something that is something clumsy. So what I'll do, this is the recent button. Go to the recent button. Go to factor analysis. It will show you the same thing that you have already done. Same descriptive is the same thing that you have already selected. Extraction is same that you have already selected. You don't have to change anything. What you can do is, suppress all the smaller values of factor loading, which is less than 0.3 or 0.4, because 40% is not what we are requiring. 40% factor loading is not we are requiring. So I'll just suppress all the values. All the values which are less than 0.4 will not be, I will not be able to see that. Just hit continue and hit OK. Once we get it, the same thing we'll be able to see. KMO is 0.9, cumulativities are same, total variance are same, nothing has changed. Only thing that you are able to see is the component matrix and rotated component matrix that has been changed. Now you can see all the values. Achha, this has come as a very perfect kind of a thing. Let me just do it again so that we'll be able to see. Just suppress all those values which are less than 0.3. Now, if I do that here, and this component matrix and rotated component matrix that I'll be seeing, that as far as the very first factor is concerned, second, third, and fourth, there are certain. So this fourth factor is having variable 1, variable 2, variable 3, and variable 4 are being loaded in the fourth factor. Every variable is having a factor loading of more than 70%. This is what we require. And this is what exactly we require. Factor loading should be greater than 0.7. If you have enough number of variables in one factor, suppose this factor number 1 is having V10, V11, 12, 13, 14, 15. Here you can keep some of the smaller values. Now, just look at some of the conditions, like you'll be able to see variable number 5 is being loaded in 2 different factors or 2 different components, component number 2 and component number 3. What do we call it? We call it cross loading. That means variable number 5 is being cross-loaded in two different components, means that has a worth of 0.576%, 57.6% of loading is being done on component number 3, and 37.4% of loading that is showing on component number 2. So there is a difference here. The difference is of almost 0.57, 0.37. There is a difference of 20%, almost 0.2. So if you are having a difference of 0.15 or greater, maybe 0.2 or 0.3, you can simply reject this one, the smaller value. But let's say, had it been this situation that and here in variable 1 the value could have been 0.600, the difference is just less than 0.1%. so in that particular situation you cannot neglect it. So for cross loading, what you can do, you can just remove that particular item which is being loaded in multiple components, right? I know the time is over. I'll take another 5 minutes and I'll wind it up, that what kind of results we get out of this facts. We know that these are certain values that which are quite, the difference is quite large that we are able to see. So we will again, what we will do, again, we know that the values of 0.374312, they are of no meaning right now. So what we can do, we can just suppress and just remove the values which are less than 0.4. We can continue, we can hit OK. And finally, we'll be able to see that rotated component matrix in this perfect condition. And again, if we do one more thing, in factor analysis, and that is, if I sort it by size, right now you'll be seeing here V1, V2, V3, everything is in a sequence. But if you want to bring sequence in the component, now the rotated component matrix that you are seeing, V14, 11, 15, 13, 10, 12, these have been, these are all together. Component number 2 talks about variable 18, 17, 16 and 19. Variable component number 3 talks about 9, 8, 7, 6 and 5. Variable number 4, 2, 1 and 3 talks about component number 4. But right now I'm concerned about, very much concerned about V6 and V5. I'm not sure I should be, because I know that the communality of V6 is very less. And I really want to get rid of that, because 6 is having low factor loading 3. So what I can do is, this component number 3 and this variable number 6 I can remove. It's totally up to the researcher. If I see overall, V9, V8 are having more than 80% of factor loading. V7 is having more than 68, almost 70% of loading. V6 and V5 are having less. So what I can do, I know that V6 is something which could be a troublemaker in the confirmatory factor analysis, because this is the weakest link. So what I can do, I can go to the factor analysis. Again, I will just pick V6 and I'll remove it from the testing block, these variable block, and I'll simply run the whole as it is. So now V6 is not there. V5 value has gone down. We can check later on. But if we check the KMO is 0.899, almost the same. Communalities has been, V5 has come down. Total variance explained is 65. That means if the values are coming down, that means the existence of V6 was good enough. We should not have removed it. But now when we see at the factor loading, the third factor is now quite in range. But by removing, we can see every factor has come in this particular format in 7. So if I compare it with the previous results, so keeping V6 was something which was having every factor loading above 8, majority of the factor loading above 8. The overall total variance explained was 64%. Now the total variance explained is 65%. Good enough. So total variance explained has improved. KMO right now is 0.899. KMO earlier was 0.902. So there is hardly a slight difference is there. But because of that, if now it is totally up to you. None of the things, like, if you try and find out that what exactly is happening, what exactly you should do, whether you should be taking it up or not taking it up, because Many of the things are being, affected. This is being, KMO is being affected slightly. Overall communality of V5 and V7 and others are coming down. So whether you should do or not, but everything is range, like it is 65.866%, or rotated component matrix is coming in this particular way, and they are taking one more iteration. That's fine right now. So it's totally your choice. You are the best judge that whether, now what you can do is you can go back again to the whole set, to the questionnaire, and you can see whether this question number 6, variable number 6, was a very important question or not. If you think that question is somehow covered in other questions, you just remove it. Like if we say that variable number 4, 2, 1 and 3, these are 1, 2, 3 and 4, all these are sufficient, more than sufficient to cover the third component, fine. But if you think the existence of variable number 6 was very important for this component, you can definitely take it up. You can again go back, and as a final result, what you can do, you can just pick it up, put it in the testing block. It will come at the last. You don't need to worry about it because you have already sorted it by size. Hit OK. You'll be able to find the whole results like this. So the every result is same, and you will find this this thing. So just right click it, copy it, and you can use the same thing in your confirmatory factor analysis. As far as your MOS, SPSS is having another version that is called MOS, analysis of moment of structure. You can just paste it in that particular window and you can utilize it further. So this is how exactly we create the groups, we sort the groups, we check the basic assumption of multivariate analysis by testing the normality, by testing the linearity, homoscedasticity, multicollinearity, and reduction of the correlation of error. After doing that, we can directly come here and we can do the factor analysis of all the questions that we are having. So I guess this is it from my side today. And if you have any query, you can please ask, and then we can wind up this session.
Yeah, hello. Good afternoon, sir. Actually,
Yes,
I'm extremely sorry. I just got disconnected from my laptop, and the moment I entered login from my mobile phone, so it is not showing the feedback form. So if it's possible, then could you please share it?
Okay, that will be provided to you by the host and the coordinators. You don't have to worry about it. You'll get it definitely.
Yeah,
So
and thank you so much for the information. Like whatever you shared, it was pretty, like it was literally great, because initially I don't have any idea what the factor analysis was, but
okay.
like till this, and I still know 20 to
Okay,
25%.
I have
So yeah,
attended more
thank
than
you so much.
10 workshops. Then only I was able to understand a bit of it. In the very if this session has helped you to understand 25% of it, you have done much better than me.
And Dr. Anwar, I have
Thank
one
you
question.
so
I
much,
just
and
missed
all the
out that
very best.
point wherein one factor is loaded on one variable is loaded on two factors. How to decide upon it?
Okay, I'll share my screen one more time, Professor Sapna.
Yeah, thank you.
Can you see the screen now?
Yes, the second or third, analysis.
Here, right now, here.
Yeah, this one.
So suppose there is a, let's say variable number 10 is being having their loadings on two different components, number 1 and number 2. The values are 0.738 and 0.31371, right? That means variable 10 is being loaded on component 1 with a weight of 73.8%, with its original weight of 73.8%, and variable 10 is being loaded on component 2. That means, let's say component 1 is about quality perspective, component 2 is brand perspective. I haven't decided anything. Ye pura data, this data that I have taken, this is from the perspective of job satisfaction and everything, but you don't know it. I don't know it. What question was, I don't know. So let's suppose component 1 is about brand, component 2 is about quality. So this product is providing you with talking about the exposure of the product. So this exposure is something which is related with the brand. If some brand equity of a product is enough, the exposure will be good. And
Yeah,
as far
that
as
I
quality,
understand without taking
yes,
much of your time, because that I understand the
yes.
theoretical background of it, because this variable must,
Now
related
what you
more to that component.
yes,
I want to ask is when the difference of the value is a little bit, for example, 0.738 and 0.708,
okay,
then how
fine.
to decide upon?
Now suppose it's 0.7, keeping this particular variable, and that higher value is with component 1. But right now, situation that it is being loaded here. Unfortunately, when the cross loading is there and the loading in each of the component is very much similar, we somehow have to remove that particular variable from the study. Even if they are having a good enough loading, maybe they are having good enough. But before that, what we can do, we can check for some associated variables. Maybe V10, V11, V12, every variable are being loaded in the same component. What we can do, we can look for some of the weaker section in this complete set of variable. Let's say V13, variable number 13 is the weaker section here. What we can do, we can just remove it. Right now, V10 is the weakest one. So what we can do, we can simply just remove it, because we will be very much okay with V11, 12, 13, 14 and 15. So removing V10 will not create a problem for us. But in certain cases, when you are not finding any solution, you are not able to find another weaker link, you have to remove that. If you will keep it there, if there will be the loading will be on two different factors, you cannot proceed with good results, because that will again create some kind of a problem at a later stage in the confirmatory factor analysis stage, and finally in the structural equation situation also, that will be creating some problem. It's better you get rid of it in the very first phase, that is exploratory factor analysis. This is my suggestion right now to you guys, but it depends on situation to situation. You can have some discussion with the experts at that point of time when you are having such kind of a problem. You will definitely find some good solutions.
Thank you.
And sir, variable reduction solves many problems. Like when I started with 16 variables. I was very
Right.
optimistic about taking all possible variables, but then my results were not very satisfactory. There was very problems in the rotated component matrix and other things. So I came down, jotted down to 12. Then I came down to 8. So the results were getting better with the reduction in the number of variables.
Professor Anita, the problem doesn't lie with the software. Software is something that will help you to, find the answers easily. That's it. We have to work more on the questionnaire part. That is the, sad thing, that we do
Yeah.
not work on the filtration of the questions. We do not use the questions, or we do not work on the question aspect. We do not go for the pilot survey. These are the problems that are, brought in all together. And that's where these problems, where you have to, reducing the dimensions time and again, and you are left with either half of it. You started with 25 and finally you are left with 12 or 10 or even less than that. So this is the problem that we usually face, because we have not worked properly on the, we what we do, we just take up the question and we start taking the, responses. This is what exactly we have to avoid. First, we go for the pilot survey, then only we'll be able to, do something better with our results.
Okay. Thank you, sir.
Pleasure. I can see there are two hands. Yes, sir. Yes, sir. Please.
Sir, actually, just one thing, sir. Sir, as you talked about the pilot survey,
Yes.
So how many responses should be there in the pilot survey? Like any thumb rule for that?
Well, usually when we look at the thumb rule for normal SPSS EFA or something, in pilot survey we do the EFA only. But doing any kind of anything from the perspective of factor analysis, be it EFA or CFA, it's better we take minimum of 5 times. If we are having 20 variables, at least we should get 100 data, so that we can run the whole set of data on the software in a proper manner. Otherwise, we might not be getting the good results. So as far as, even if for pilot survey, do not go with the smaller. if you are much sure about the questions that you have taken, that the questions are standard, that has been already taken somewhere else, you can definitely do it. You can take some smaller values, but it's always you take value minimum 5 times of what the number of variables are.
Okay. Actually, I'm facing a problem. I'm working on a project where where the focus set is very limited. Like I am looking at data only from logistic companies, senior managers,
Okay.
something like that. And another problem is that I have a lot of questions. Like I have 49 questions in the questionnaire, and all are drawn from the different.
What do you think, sir? How many number of variables you'd be able to find out of those 49
For
questions?
variables, maybe around 7.
7. Okay, there is again another thumb rule that we can talk about. That thumb rule is basically, I'll just stop sharing. The thumb rule is basically that says if you have one variable, do not have more than 7 questions. So there is a minimum of 3 and a maximum of 7 in every variable. Suppose if you are having one variable, take 5 questions or 6 questions. We know that in dimension reduction, we can reduce 1 or 2. You will still be good with 3 questions for one variable.
Okay.
But work more on the conceptual part. If your concept is strong, even one of my what happened with one of my desertee, she was in MBA. She did the same thing. She was working on supply chain performance.
Right.
She just took data, and the problem that she faced was the same one, that she was not able to get enough data.
Yes.
So since she was an MBA student and she did not she did not work more on the perspective of bringing the model good enough. There was the whole issue. Had it been she decided her model in a very proper manner, then with the limited set of data she could have done wonders. But yeah, she did find some reasonable results based on which she submitted her dissertation of.
Okay.
Right.
So in my case, I shall try to reduce the number of questions.
Yes, just try to see which are the two questions which are very much similar to each other, and you can remove one. Or what you can do, you can refer back to the literatures that you have referred to, and you can see which of the questions are good enough that you can be keeping, or which are the questions which are having good factor loading in that particular research, and that you can keep with yourself. Rest of it you can just remove.
Right.
Keep 4 or 5, maximum 6, not more than that.
Okay.
We have two raised hands. One is Satyakam Pandit sir and Dr. Reena. Do we have can we have questions from you, Dr. Reena and Professor Satyakam?
Yes.
Or maybe Professor Pradhan? Yes, Dr. Reena, please.
Yeah, so I wanted to ask one question. What is the difference between factor analysis and principal component analysis?
Principal component and
factor analysis.
Okay, there's no difference as such. Factor analysis does many things. It reduces the dimension, it's something, and it helps us to make multiple groups of all the questions that we have asked, right? So, principal component analysis is a method of extraction. If we have 20 questions altogether, and out of 20, we may want to make groups. Principal component analysis takes into account the principal characteristics of the questions, and it helps in making the groups for us. And same with maximum likelihood. They takes into account the major characteristic and they divide the groups. Yes, sir. Professor Pandit, please. Professor Satyakam Pandit, if you have any query. Professor Pradhan?
Sir, good afternoon.
Yes, Professor Pradhan, please.
My question is that then you are using to the community. And then you are using to the community.
Okay.
How do you explain the community? Can you explain? I'm not getting the community part.
Okay, communality part. It's something, sir. Communalities are something that you have taken. We know that there is. Okay, how do I say this? Have you ever made a drink of using ruafza, water, sugar, and other things? What do? You take into account all the important ingredients and you mix that, right, sir? So it's basically there is a system that you have created out of all the components, all the important ingredients that you are having. So this communalities tells us that you have used sugar, you have used water, you have used ice and other things to make that sharbat, that drink, that sweet drink to have. How much role, how much they are deemed fit. I can also include, maybe I can include some masala into that, maybe Maggi masala into that. But would that be good enough? Communalities tells us that if we include any of the questions, it's basically like how well that will be fit into that particular system. So some of the communities was having 57%, 0.5, 0.6. So those having communities better, they are better fit in that particular system of all the questions. This is the basic worth of the communalities. We will have quick questions. Professor Jamshed, Dr. Jamshed, can we take quick questions from one or two? You are muted, sir. You are muted.
Participants, actually, we are crossing the time limit, and we have something in our mind. So please, stay. You can contact us.
Sir, Dr. Jamshed, can I have a basic request from you?
Yes, please.
This is also important from our perspective as a resource person. Maybe all the participant can write down their query in the chat box. You can just have the, you can consolidate it in one place, maybe one Excel sheet, and you can provide it to me. I'll give the answers to those questions in the same Excel sheet, and you can share it with the participants. Would that be good enough?
Yes, it would be better that if you can share the email ID so that they will contact you.
Okay, fine. I'll just write down my email ID here.
Sir, please. There are some announcement from our side for that for the concurrent sessions. If you have any query, you can contact directly to Arif Anwar sir, and he will Professor Arif Anwar will reply accordingly. And Dr. Asu sir, please.
What I want actually is we'll be needing three, say, volunteers for every day. We'll be introducing the resource persons actually. So if any one of you is interested for tomorrow's session, the moment you agree, I'll be sharing the, say, profile of the resource person with you. Else, what I have to do is I have to pick up voluntarily. So it is better that if you just come up and then say that, yes, I'm going to introduce. So that means I should just believe that I am supposed to just pick up names voluntarily. Rahul Kumar, do you want to, you are supposed to?
Yes, sir.
You're not audible, Rahul. No, so what we are going to do, we'll be just contacting you directly. Fine, I'll be just picking out 2 or 3 names for every day, and then I'll be just sending you the profile of the resource person.
Hello. Sorry, sir, I lost a connection, so I didn't hear you properly.
Rahul,
So
you are trying to say something, but I don't think you are.
Sir, I connection, sir.
Okay, fine.
Please write down in the chat
Rahul
box.
And is there anyone? Okay, Fakhruddin Sheikh. What you can do is please drop me a message in my WhatsApp number. So I'll just send you the profile of the resource person.
Sure, sir.
Fine. And anything else? So Dr. Arif Anwar, I'm really thankful to you actually that you accepted our invitation. And you just talked something which is very relevant. And then if we talk about this factor analysis thing, in the initial stages, when we start actually researching, we find it very difficult that what is actually happening, or say if we talk about the data actually which comes in front of us, we find it very amusing actually. And then at times we get say a bit worried also, as a few of the participants actually ask questions related to that also, that how all these things are happening, as well as what to do actually next. If I'm just removing certain say item, why are we removing that item? So I hope in the coming days we'll be learning more about these things. And then I'm really again thankful to you, Dr. Arif, that you accepted our invitation.
Thank you for providing me the platform, Dr. Sir, because had it not been the situation, I would not get this particular opportunity. Thank you for creating such a wonderful platform.
So, anyone else who is having any kind of question to us, not to Dr. Arif Anwar, because this, we can call it a day actually. Anyone? Yes, Swati, you have any question?
So, can you please different component and table of component matter? Because
Your voice is breaking. The thing is, you're not supposed to ask question to Dr. Arif. that was the actual thing. So, Swati, I hope that these things will be say more clear in the coming classes. I do believe that.
thank you so much.
Okay, take care. So, Dr. Arif, again, thank you. You can leave.
Most welcome.
Okay, take care. And, so, participants will be meeting tomorrow sharp at 9. So please make sure that your attendance is being recorded by the Google Meet platform only. So we are not just taking any kind of attendance. So this is your responsibility. Yeah, one more thing before you all leave, actually, because many of you have left, that make sure that your camera is turned on. Because many of you, most of you actually are just don't turn on your camera. So it's just better that if you turn on your camera, and then I think it would make the class more interactive. So I'm not asking to turn on your camera at this point of time because everything is done right now. What we are supposed to do is whenever you are attending the sessions, please make sure that you are just turning on your camera. Fine, it's a request, as well as I don't know what to say, but make sure that you are turning on your camera. Fine. Any other question? I hope you like the sessions.
Yeah, Dr. Sir, I
Yes,
just
sir.
wanted
Yes, sir.
to know about the test that would be held. If you can tell us what sort of test will it be at the end of the
That will
this
be an MCQ one, Wakas. And the sessions actually you are just going through. The questions will be from those sessions only. Okay.
Okay, means the technical questions about all the sessions.
Yeah. It depends on the actually resource person actually, because they would be the one actually who will be just providing us those with those questions.
Okay. Thank you so much, doctors.
Okay. Take care. And have say what we call it a day. We'll meet tomorrow, inshallah. Thank you. Thanks a lot.